Hello, I'm Peter Ferrie, and this is my talk about the creation of a new version of DOS and a new text editor to go with it. The motivation for this topic is that we are actively preserving disks before they fail completely. That often requires boot tracing the contents of the original disk and then saving them to another disk. If the copy protection requires that we disassemble the code because we can't understand it immediately, then it's best if we can load the code to the original address so that the disassembly matches the original code. That brings us to the biggest problem that we have, which is that regular DOS uses a lot of memory for itself. That means that we often can't load the copy protection code to the original address because it would conflict with DOS. Instead, we get to boot trace the title until the protection triggers, then we boot DOS, then we save whatever pages are not touched by loading DOS, then we boot trace the title again, then we copy the pages that will be overwritten by DOS to addresses that won't be overwritten by DOS, then we boot DOS again, and finally we save those pages to disk. This is the memory map with DOS loaded. This is where the boot sector is loaded, so it's always going to be modified. And here is DOS stomping over a big chunk of memory. That leaves this little region of memory that's preserved across reboots. And this is the reason why we choose DOS over ProDOS, because in ProDOS this region would be even smaller. One idea for fixing this is Diversi-DOS. Diversi-DOS is based on DOS 3.3, but it has an option to allow it to run from the language card and free almost all of main memory. It has some bug fixes and other features that some people might find useful. In particular for us, it can save files that are larger than 32 kilobytes, which is very useful now that we have more free memory. When Diversi-DOS runs from the language card, it needs only one page at the top of memory, just like ProDOS. This is the memory map when Diversi-DOS is loaded, which looks really great. As before, the boot sector is loaded and modifies this region, and that's fine. However, the loader stomps over an even larger chunk of memory than DOS 3.3 does, which means that we have an even smaller region of memory that's preserved across reboots. That's not okay, but let's go with that for now, and let's talk about ForLive for a while. The preservationist, known as 4am, wanted to create a text editor that he could use to document the preservations as he was working on them. He wanted this text editor to be as small as possible, but still have enough features to be useful. It had to be a terminate and stay resident program, just like you find on the PC. That means we can switch to and from the editor at any moment just by pressing a hotkey. Activating or deactivating the editor had to switch between the real text screen and the editor text screen. Whenever the editor is deactivated, it had to automatically save the editor screen and the cursor position so that you can continue editing across reboots and exactly where you left off. The editor had to allow free-form typing so that you can use the arrow keys to move the cursor around and type over existing text, and typing to the end of a line would automatically wrap to the next line. And it also had to be able to import the real text screen into the editor screen to allow annotation of disassemblies. The first version of ForLive was less than 2 kilobytes long, and it ran from 8000 onwards. It allowed you to type on only one page of text, and it only supported uppercase text. This is the memory map with ForLive loaded and Diversi-DOS running from the language card. As before, the boot sector is loaded and modifies this region. And here's the region that's preserved across reboots. That wasn't good enough for 4am. So for the next version, we added support for lowercase text. If lowercase wasn't available on the system, then ForLive would convert automatically any saved lowercase to uppercase for displaying on the screen. But it would maintain the lowercase text internally unless you typed over it with uppercase text. That allowed you to copy the editor file between machines and still have it readable everywhere. Then we moved ForLive itself into the language card. This is possible because Diversi-DOS uses only one bank of RAM, so we just loaded ourselves into the other bank. And that means that most addresses in main memory were now available for loading code and disassembling directly. This is the main memory map with ForLive version 2 loaded and Diversi-DOS running in the language card. The red section was a swap space that we used when switching between the real text screen and the editor screen. The problem is that since we're running from one bank in the language card and Diversi-DOS is running from the other one, then Diversi-DOS can't read or write the contents of our bank directly. Instead, we have to copy our bank to somewhere in main memory and then ask Diversi-DOS to write from that memory region instead. Or we have to ask Diversi-DOS to read into that memory, and then we copy that memory into our bank. Here's the memory that's modified by Diversi-DOS being loaded, and here's the region that's preserved across reboots. That still means that you get to boot DOS and boot and save like we did originally. But now the protection code can be mostly loaded to its original address, and you work from there. That wasn't good enough either. Here's a crazy trick that you can do in DOS. Since DOS files have a track sector list to link together all of the sectors that belong to a file, but binary files also carry their file size internally, there's no requirement that the two values match, because otherwise you'd need every file to be an exact multiple of the size of a sector, and then you couldn't have 1-byte files or anything small like that. But more than that, we can create a file that spans more than one sector and still set the internal size to be less than a sector, for example. At that point, everything beyond that internal file size becomes appended data that won't be loaded by DOS when the file is loaded into memory. We can use that fact to allow overlays within our own file. DOS also has an API for file accesses that is apparently not that well known. If you've ever looked at the loader for the popular file-based version of Wavy Navy, for example, it passed the track sector table itself and called RWTS directly to load the remaining sectors. But there's a simpler way to do it, because there's an API known as the File Manager. It has support for opening, seeking, reading and writing of files. It can also create and delete files. Calling the File Manager is just a matter of filling a structure and then passing to the File Manager a pointer to that structure. It looks very similar to what ProDOS used later, so perhaps this is where they got the idea. We can use this API to open our file, seek to the overlay data, and then read those data directly into memory. We can even do that more than once if we have multiple overlay regions in the same file. Now our memory map looks like this, with 4Live version 2.1 loaded and Diversi-DOS running in the language card. You can see that the swap space has been reduced significantly, and we're using just a small section of very low memory. Here's the memory that's modified by Diversi-DOS being loaded, and here's the region that's preserved across reboots. The sliver of blue next to the swap space should really be red, because that's the rest of the sector that the boot uses. That wasn't good enough either. So I shrunk the memory use in the low part of memory, but kept the swap space the same size. Here's the memory that's modified by Diversi-DOS being loaded, and here's the region that's preserved across reboots. You can see nothing has changed there. So that wasn't good enough either. Here's another crazy trick that we can do in DOS. If we are really careful about how we lay out our code, we can load our overlay directly over the code that's running, and then the CPU will fetch the new content instead of the old one. All we need to do is duplicate whatever small part overlaps the two regions. For example, if there's a subroutine that has to return a value after reading the overlay, then just that return instruction has to be duplicated, while everything before it and after it can be replaced uniquely. DOS doesn't care if we do that. In fact, DOS doesn't even know it's happening. So with that in place, you can guess what's coming next. At that moment, we had lots of space available in our bank of the language card. It seemed a shame to leave it like that, so wasteful. So we began a quest to fill it with features. We added a feature that highlights certain lines for emphasis, or perhaps you could use it as a bookmark for your disassembly to revisit later. You can also unhighlight those lines at any point, and that works even across reboots. We increased the number of editor pages to a maximum of 99. That's not a technical limitation. We're actually limited only by available disk space, but we didn't want to track more than that, because if you need more than 99 pages of text for your write-up, then this might not be the right environment for writing that text. There's a page number that's displayed in the status lines so that you can keep track of where you are in your write-up, and there's a hotkey for moving backwards and forwards between the pages. So now it functions like a real word processor, and you can write tons of stuff. And it still fits in under 2 kilobytes of memory, since that's all the memory we had available after we were done. Now our memory map looks like this, with 4Live version 3 loaded and Diversi-DOS running in the language card. You can see that the swap space is gone from the main memory. It's actually within our bank in the language card, which is why we're so short on memory space. In order to swap between the editor screen and the text screen, we save the original main memory contents into a portion of our bank. Then we copy the editor screen from our bank into main memory and ask Diversi-DOS to save it. And then we restore the original contents from our bank. That's nearly a kilobyte of memory alone for the swap space. Then there's another near kilobyte of memory for the editor screen. That leaves us only about 2 kilobytes for code. As before, the boot sector is loaded and modifies this region. Here's the memory that's modified by Diversi-DOS being loaded, and here's the region that's preserved across reboots. But we're not done yet. Let's look at this again. We can't do anything about the boot sector, so we take that away. But what if we could do this and make that whole region preserved? Well, it turns out that we can. Our solution was something that we call Directi-DOS. We used Diversi-DOS as our starting point. Then we used an emulator to trace and capture the relocated image from the language card. And yes, I could have done this on real hardware, but it wasn't necessary for our purpose. We wrote a new bootloader that loaded the image into the language card directly. That's why we chose the name Directi-DOS. So there's no intermediate use of main memory. Just imagine that. That means that main memory from 900 to BEFF is maintained across reboots. Here's a memory map with Directi-DOS running, and that's a whole lot of green. But you know what? It was still not good enough. Directi-DOS wasn't good enough. It was too big on disk. So we compressed the image until it fitted on only 2 tracks of the disk. Now we have a complete image of Diversi-DOS loaded and running directly from the language card. And that's on a disk with 16 more free sectors available compared to DOS 3.3. That's a whole extra track for storage. It's even smaller than Pronto-DOS, which was the previously smallest DOS available. You can see a demo of Directi-DOS running 4Live and the features of the technology on archive.org. And here's the link to that video. And finally, our memory map looks like this, with 4Live version 3 loaded and Directi-DOS running Diversi-DOS directly from the language card. Thank you.